discrete structure at sa topic na tree graph theories. Tree diagram. A tree diagram is a simpler way of representing a sequence of events. Tree diagrams are particularly useful in probability since they record all possible outcomes in a clear and uncomplicated manner. Root. The root node may be considered the top if the visual representation is top-down or the bottom if it is bottom-up. The analogy is that the tree starts at the roots and then goes up to its crown, so the first node is considered the root. Siblings. Siblings nodes are nodes on the same hierarchical level under the same parent node. Nodes higher than a given node in the same lineage are ancestor, and those below it are descendants. Leaf. Node at the end of the branch that discerns with decision class the associated branch classified to. It is a node not further split the terminal groupings in a classification or decision tree. Internal node. An internal node is a node having degree at least 2, meaning that the node does not represent a leaf. In the tree shown below, all internal nodes have been color black and all leaves have been color white. Degree. In the study of graphs and networks, the degree of a node is a network is the number of connections it has to other nodes, and the degree distribution is the probability distribution of this degree over the whole network. Edge. The three data structures, the connecting link between any two nodes, the called is edge. In a tree with n number of nodes, there will be a maximum of n1 number of edges. Path. In a tree data structure, the sequence of nodes and edges from one node to another node is called as path. Between the two nodes, length of a path is total number of nodes in the path. In below example, the path A, B, E, and J has length 4. Level. A tree data structure, the root node is said to be at level 0, and the children of root node are at level 1, and the children of the nodes which are at level 1 will be at level 2, and so on. The important thing to remember is when talking about level, it starts from 1 and the level of the root is 1. We need to be careful about this when solving problems related to level. Depth. We just count how many edges between the targeting node and root in the root, ignoring directions. For example, depth is 2. Recall that when talking about height, we actually imply a baseline located at bottom. For the path, the baseline is at top, which is root level. That's why we call it depth. Forest. Forest is a collection of disjoint trees. In the words, we can also say that forest is a collection of cyclic graph which is not connected. Here is pictorial representation of a forest. Here you can see that there is no connection tree in the example. A single tree and empty graph is also an example of forest data structure. Height of tree. The height of nodes is the number of edges of the longest path from the node to a leaf. A leaf node will have a height of 0, and the number edges on the longest path from the node to a leaf. A leaf node will have a height of 0. Height of node. The height of node is the number of edges on the longest downward path between that node